welcome to the last presentation. Open source this. Daniel, show us how.
Okay, thanks a lot. So I'm Daniel Bovensiepen, and I have two messages for you, a bad one and a good one. So the bad one is this will be an AI-related talk, but the good one is that it's the last AI talk for today. So there's something positive here to get out. Actually, 3 months ago, when I was thinking about what kind of talk I want to give, I would not have thought at all that it will be about AI. But then, sadly, I procrastinated the CFP, and when it was actually time to submit, I actually stumbled over this article. And I'm not sure if any one of you have seen that. If not, then just a brief summary. There is this Python library called Sharded, and maintainer of this library actually decided for version 7 to rewrite this Python library. He didn't rewrite it in Rust, he rewrote it from Python to Python. But while doing the rewrite, the interesting was that he did it AI guided essentially, and at the end, he considered himself to be in a position to change the license. So now I'm not an open source fundamentalist. In the end, he changed it from LGPL first to, I think, MIT and then zero clause BSD. So it's still open source, but something stuck with me when I was reading that, because I thought, hypothetically, if I would work for a company who is selling proprietary software, and I'm seeing that, then I have somewhat a hard argument, why should I respect any kind of open source license? And that obviously made me a little bit angry, to be honest. And I know usually if you're angry, the first thought is not a good idea. So I thought my proposal for this talk should be something like, let's turn it around. So let's say instead of removing open source licenses, why can we not just take proprietary software, throw it into an AI, and have AI-assisted, essentially, open source generation? So now I know the proposal is a little bit juvenile, so I was thinking a little bit, okay, maybe I can do something better, a little bit more constructive. So what I want to do today is actually to go through with you through the process of having an artifact, reverse engineering it, writing a clean room specification, and then re-implementing it. And then looking a little bit what are the consequences out of that, and of course, most important, doing it essentially with AI, so that, that the audience is fitting. Okay, with that said, let's get started. A brief introduction to reverse engineering. So I know probably most of you maybe think reverse engineering is kind of a dirty thing, something like only nefarious people are doing. Maybe some garage hacker who want to break in somewhere, or some evil corp who want to steal trade secret. But I want to make the claim, and if you take one thing with you today, is reverse engineering is a great thing. It's a very positive thing, and only a very minor amount of usage of reverse engineering should actually be considered bad. Most of it is actually pretty good. And I give you some examples so even ChatGPT actually considers it to be a problem from time to time. I still need to register for the trust access. Either way, I give you some examples for why reverse engineering is actually a good thing. So one thing is actually now research and study. So one thing I do at work quite often is to procrastinate, and then I surf a little bit around on Taobao and look at some gadgets. And what I found actually now recently was this kind of gimmick here, which is a device you put into your car's cigarette igniter, and then it claims that it will reduce your fuel usage of your car. So that seems quite amazing. I mean, I like to learn things, so we could apply now reverse engineering on top of that one. So one thing is we could do a black box reverse engineering. We could maybe put it into an ICE engine first, and then afterwards into an electrical vehicle, and see, does it also save actually battery? Because if it works for 2, then maybe we can now reverse engineer the working principle. Or we could cut it a little bit short and just take it apart and have a look at it, and then we see there's actually a capacitor and some resistors and LED inside, and the only thing what it's doing is actually glowing blue. So it's obviously a scam, but it's interesting to learn. I mean, we do not really learn something technically here, but we learn a little bit about society, which accepts to have these kind of products. Another interesting thing is interoperability. So I guess there are a lot of Linux users here, and you make a lot of fun in the past about the fruit company users, but actually it's hard time for the last 6 years to make fun of them because their hardware is so impressively good. So actually this project actually brings Linux to the Apple Silicon, and the majority of that work is actually done based on reverse engineering because obviously Apple doesn't release their specification. Another example is digital preservation. So many of you might know that the best games actually were developed in the 80s and 90s. And if we wouldn't have this kind of old console anymore, they're all falling apart. And if there wouldn't be people who reverse engineer the hardware and the game engine and bring it to the current platforms, then we couldn't play these amazing games anymore. Then we have cars, so there's the right to repair, and that's a really nice thing to have. But what is it good for to have a right to repair if you're not able to actually repair something because you do not know how to talk to your car? So there are huge open source communities who actually do reverse engineering of the canvas and in a diagnostic port of your cars so that you actually can do it by yourself or by a small car repair shop instead of going to the big car shops. And then something which goes a little closer to home. Every now and then, some guys come by at my desk and put a piece of hardware on my table and say, we have the theory that this company is duplicating something. Actually, this one is the Siemens one. So we have this theory that this company is infringing our IP. And I mean, I'm thinking positive. It could be that it's just accidentally looking the same, it works the same, it runs suddenly also our software, and it's compatible to all our products. But of course, it doesn't say a lot. So reverse engineering is one approach now to figure out, okay, does that thing actually now have some of our trade secrets or is it infringing our IP? Very common. So with that said, I hope I can make the point that reverse engineering is by far a nefarious thing. It's something everybody should do to actually learn more about this amazing world we are living in with all the gadgets around us, no matter if it's software or hardware. So there are then, of course, strategies of how to do that. One approach you probably could understand is you take an artifact, might be a software, and you do some kind of static analysis of it. But then you can also approach the problem, of course, of checking for the behavior. And so, for example, keep the system running and check what it's doing and then derive out of that one how it's functioning. And my hypothesis here would be that things like static analysis and protocol tracing should be something an LLM could assist us, because in the end, it is kind of a pattern matching. And this is actually what I would like to show you now. But in the beginning, I was actually thinking I should probably now introduce every single of these strategies to you and give you a prompt for it. But then I actually noticed, this shouldn't be a prompt engineering talk. And as a matter of fact, having all these prompts cascaded gives you a reliability of maybe 80 to 90% that certain things work again and again and again. So that's not very helpful for you. So instead, I would like to go with you through 3 case studies today, where I essentially took 3 kind of products for this presentation and show you how that actually could be done. So first of all, let's think about what would be a good device to reverse engineer, considering that an LLM is not really reliable. So the reverse engineering done by the LLM might not be very accurate, but also the reimplementation might be full of bugs. So what would be a product which is ideal to handle these things? And I think it's obvious, it's of course medical devices. So more specifically CGMs. So a CGM is actually a continuous glucose monitor. The working principle is that you essentially shoot an electrode through your skin, and then it's actually measuring the molecular count of the glucose elements inside. Then there are these days, of course, a battery inside, of course, and everything has Bluetooth. So it then sends you essentially telegrams to your phone and then plots it essentially. And I hear some people use it for diabetes, but actually we had a look at it because a colleague of mine wanted to run a half marathon, and we wanted to optimize to figure out when is the best time during this marathon to actually add some energy into it, because you could actually measure that out of the glucose. A much better use case. And if we actually could now remove the mobile phone and instead maybe put a Linux device in between, I could actually, like in Formula 1, remotely actually see his glucose values, which is of course a very interesting case. So how would be the procedure? So the number one important thing if you essentially start to reverse engineer something is that you build some kind of test harness where you are in control of the environment of the device. And I mean, one way would be that I shoot that into my arm and then I drink a lot of Coke and see, okay, now the glucose value is increasing. So now these bits in the protocol should be increasing. But as I learned, that actually takes quite a long time. So instead, I actually created this kind of test setup on the right side. I didn't have anything fancy, so I just used honey and salt water so that I can actually create a solution where I say, okay, I start with a little bit glucose and then I increase it so that I can see, do the bits change? So then we want to have it on a Linux system running. Most notebooks these days have a Bluetooth interface, but we want to use a programmable one because we also want to follow the device when it's frequency hopping and we want to sniff, which is not necessarily always possible. And then essentially we started and took the original APK, so the APK you have from the Android app, and actually push it into the LLM and essentially guide it to perform a static analysis of the code and then create a clean room specification. You can essentially imagine it as a markdown document which doesn't just document the exact code, but documents what it believes the function of this app is. Afterwards, we take this clean room specification and generate a Linux application. And then, to be honest, it didn't work immediately, but after certain iterations, so we did perform some dynamic analysis. So we started to interact with the sensor. At the beginning, it believed it was a Bluetooth device, but it was actually a Bluetooth low energy device. So the behavior was a little bit wrong. And as a matter of fact, it's actually what you see there at the moment. So actually, I have this sensor here shoot in, and this one is actually capturing now the readings. And as a matter of fact, and that's very important if you reverse engineer something, you need some kind of baseline. So I shoot another one in this arm, and I'm actually synchronize that with the official app so that I can see are the values actually plausible. Okay, so case study number one. Case study number two is a little bit more close to home, so maybe you know, maybe you don't know. Siemens is actually building 5G systems in the infrastructure and the terminals, but actually we do not always sell to all customers both sides. And 5G is a very complex protocol, and different vendors actually interpret it a little bit different. So if some customer actually maybe want to save some money and buy the infrastructure from someone else, but use our terminals, then they actually might be in conflict. So maybe the protocol is interpreted differently. And for actually diagnose that, it's so common that most baseband modem provider or module providers give you a diagnostic tool. But these diagnostic tools usually run on Windows, which might be okay now if you just do it shortly, but we actually had in the past some issues where maybe once in a half moon an error occurs. So we had actually to have a system which runs for a very long period of time. And actually, there's a lot of data being created from the signaling. So I think a very good use case, again. So could we not just now take this app, in this case it was a Windows app, the C++ one, perform again a static analysis, create a clean room specification, and I hate to say the word, but we really one-shot a Linux implementation. So really the very first implementation immediately worked, which is quite helpful because in this kind of process, I never needed to start any kind of Windows PC. And that's something very special because if I would have performed the reverse engineering, I would have created the Windows app, PC, started the app, and then look at the protocol, and then essentially try to figure out how it works. So here the whole Windows part completely was removed because we could do it completely statically. And then we performed actually the plausibility check with old log files. So that's actually nearly an order of magnitude less effort than for the first process. So now we have these two use cases. We could say some of it probably works very well because the LLMs already know a little bit about the protocol. So what about taking an app which is a little bit more complicated? But then again, we need to find an app which at the same time where it doesn't really matter if it's actually not working so accurately. So I was thinking, what would be a really good app to look at? Now, which we could check. So now that this gag only works if you are working at Siemens. If you might not work at Siemens, then let me explain. So At Siemens, we have a zero trust endpoint connector. So this is a tool for desperate users who just want to access the internal and external network resources. It does a lot of cyber security stuff additionally, but in the end, it's a VPN, even if all the providers claim it's something more. The challenges we have, or I personally have, maybe other people are okay with that one, is that the protocol is proprietary. It's optimized for Windows and Mac. The Linux exists, but it's not really good. It's actually really, really bad. And it lacks support for the latest distribution. And also, it's not really flexible, so I always need a GUI to have it running. So maybe to just cut it short, because I'm running a little bit out of time, let's have a look. So this is an Ubuntu 26.04. So this client does not exist for this distribution. Let me just show you briefly that we are here in a network which is not zero trust anything. So I just show you my IP. So this is from my home one. It's in China Unicom Beijing. Maybe you just remember it's starting with 2221. Then we go to the diagnostic website of the zero trust infrastructure, and we will see that we are not inside of the zero trust network. And then we have another check about the speed test, which only works if you're inside of the zero trust network, which doesn't work, so this doesn't resolve here. Okay, so now let's have a look if the reimplementation works. So actually I told during the clean room specification to re-implement this thing actually in Ruby. And instead of actually implementing it as an IP routing based system, I said, remove all these IP routes, I want a proper proxy. It's much better to be integrated into my workflow. So essentially here we now activate the proxy from this re-implementation, and let's have a look. So here with IP 221, when we reload it, we are in the zero trust network now. So obviously Cloudflare is now afraid about it because it's not too secure. And then you will see that we are now actually coming out from another access point. We have 202 and from Beijing Tianweixin, which is actually the ISP from this company. So if we are really running the diagnostics, so now actually the system understands, oh, we are now inside of the zero trust network. That's surprising. And then also we can start actually the speed test, and we see, yes, we are indeed inside of the zero trust network. It recognizes that we are inside of the tunnel. Yeah, it is actually working. So what does it take to do something like that? Because the tool has a certain kind of complexity. So it is more like 2 orders of magnitude more stuff we have to throw into the LLM. It took quite a bit, so a little bit more than 15 hours altogether. But to be very honest, I would not have done that now without that one. It would have taken me much, much longer. So the approach was essentially doing a static analysis of the Linux application, generating again the cleanroom spec, but then I changed the cleanroom spec to essentially tell it to instead of providing me these IP routes, a proxy interface. And then we essentially generated version 1, but then we had to, I would say dozens of times iterate against the actual backend. And I was actually surprised that the zero trust infrastructure didn't blacklist me at one point, because a lot of the implementation was not really correct. But in the end, it works. I needed, though, to extract the credentials from the original app, so the whole credential workflow was not implemented, just for the sake of our cybersecurity people, that I do not get any complaints. Okay, so just now to ground, now where is this actually going? So the stuff I showed you, it is working. It's prototypes which work end to end. It is to a certain extent significant amount of money you have at the moment to sort the problem, but it's possible. But you have certain kind of issues, and this is actually now the interesting thing. If you throw the stuff into the LLM, it will tell you, I implemented everything is great, but no, nothing is great. So for example, the CGM, first of all, it loses 30% of all data. You might not have seen that, and the reason for that is actually that it doesn't implement the low power properly. So it actually doesn't put my tech into a low power mode, which actually means this side will die earlier than this side. Then, and this is actually a critical thing, the calibration doesn't really work, so I would not recommend to anyone to adjust their insulin based on this data. And then there are some other issues, like for the zero trust. Actually, at Siemens we are using the version 2 tunnel. But during the reverse engineering, I actually noticed there's a version 1 tunnel. I didn't even know that. But it actually was easier to implement. So the protocol was a little bit easier. And apparently it's still working. So I use that one from now. But to summarize, the stuff is slop. I mean, we have to be very clear about this. What is generated is slop. But it is useful slop. I mean, going through when there was this process, I learned a lot about all these kind of tools. So it actually is, in the sense of reverse engineering, very helpful to help me to understand the systems better. Also, it is motivating slop, because the biggest issue you have with reverse engineering is at one point your motivation will drop if you do not have any progress. And as you have seen, it was very quick to have an end-to-end setup, which didn't work perfectly, but at least you were at a state where you could then iterate with the full system. So this is very, very powerful, I have to say. So I uploaded some of it, not all of them, for certain reasons. And also this the slop engine, which essentially has all these prompts to go through it, I also upload. If you are interested, have a look. But only submit AI-generated code. Yeah? I do not want to see any human-generated code. So, legal. Actually, I wanted to start with legal, but if I would have done that, the presentation would be much shorter. So what does legal say? So I'm not a lawyer, and I didn't ask ChatGPT, but I did the third best thing you can do. I asked actually real lawyers. So actually, for redundancy reason, I asked civil ones in civil jurisdiction, also inside of Siemens, outside of Siemens. And surprisingly, they all gave me the same feedback. It depends. Does that actually, that's amazing. I maybe cannot really use that for a presentation. So I thought, could we maybe make a business 101 chart where I give you a jurisdiction, maybe China, Europe, and US. Then I give you a legal question about the things I just done there. And then you just give me a feedback like, how many gray hair do you get when I would want to do that at work? Or how angry or how much tears do you leave when I actually want to implement that one? But as a matter, it turns out that the Unicode emoji set is too small to replicate all the emotions our lawyers have. So instead, I think I do something better than that. I give you some of the questions they have, which guide a little bit if it's meaningful to do. So if we have this pipeline, the first question they will ask, and you should have an answer to that one, is, where did you actually got the original artifact? Did you sign NDA? Did you download it from some strange website, or was it really just freely available? So this is one they will immediately ask. For the reverse engineering, one important thing they will ask is, what's the purpose? Do you actually reverse engineer to extract trade secrets? Or why do you want to do that? I think one of the most important, and often forgot one, also this guy in the very beginning of who did charted redevelopment actually missed that. What about the leakage between the reverse engineering and the re-implementation? Do you actually have leaked things from the reverse engineering in form of code and implementation to the re-implementation? This is a no. And I know at the moment agentic AI is quite a big thing, and a lot of people say that you should use a lot of agents. I'm not sure how good that is, but here I would make a claim. It would make sense to have different agents without any context sharing for the reverse engineering and the re-implementation. For the re-implementation, then again, do you use trade secrets and IP? And then in the end, can that stuff actually be copyrighted or copyleft? And the answer, I mean, everybody has a different opinion, but so far it's very difficult, if this is all automated, to show significant human input. So I would actually say this pipeline doesn't work at all. The output cannot be licensed, but I'm not a lawyer. So with that said, summary. So I would say there's an undeniable speed up for reverse engineering AI assisted. You need to have a clearly automatable test setup against which you can run the AI. And something I would be now quite interested in is actually to integrate more hardware. So we do a lot of those wireless systems. So it would be very interesting to perform that one also on radio waves, and then essentially have an SDR where we actually recreate them. With that also, maybe the question comes up, what is open source for you? So I would say, if open source software, for example, is for you a piece of software which has a certain license, then you are in for a bad time. So I would say licenses are dead. But there is good news here. If for you open source is something you can learn from, something you can modify or control, then now the world is great because essentially everything is now open source. So with that said, AI-assisted reverse engineering changes the economic rules. That's definitely the case, but not the legal ones. And with that said, I would just like to make one announcement and I'm end. Roger started the conference yesterday with mentioning his trip to China. So we have this open source at Siemens event, which is essentially the sister event of this one. And this year we want to do another one. So we have every time, first day doing general open source and second day making something special. Real-time artificial intelligence and semiconductors last year. So this year we would like to do open source robotics. So if you would be interested in joining that one as a speaker, of course, or as a guest, feel free to hit me up and maybe we can manage to find some excuses for your manager of why you need to come to China. So with that said, thank you very much and have a nice day.
Thank you, fantastic. Can you comment a little bit on how easy would it be to automate assessment of if a certain clean room spec is really clean? Is this something you can automate, or would you ever need to go to?
I have no idea how to do that. Because to be honest, that was the reason why I said this leakage part. You would need to know that your reverse engineering activity in itself doesn't have created any kind of information which might be reused. And if you use one of these cutting-edge LLMs in the cloud, I do not know how frequently they actually train. So if I use them in one session and I start a new one with another agent, does that one maybe have already learned from the first session? So I would say, and this is actually what I try to do mostly, if I have a local LLM, I would say I'm feeling quite sure that there's no leakage whatsoever. I can control that quite good. But with commercial ones, which are somehow running in the cloud, I wouldn't know. I wouldn't trust there anything, that there's no leakage between sessions.
Just write the spec with GPT and implement it with Claude?
Yeah, but how do you know that there's not a leakage between them both?
Well, that I would be expecting not to be.
Yeah, but I mean, you have setups where a third party like Microsoft is hosting both models. So, I do not know. I do not have any further insight. I have probably less insight than most of you into all these Western AI models. But I do not know.
Great talk, thank you. How much did you have to fight token context limits or other limitations of the LLMs when feeding binary data into the LLM?
That wasn't actually a big problem. I mean, I solved the problem with money mostly. So I just subscribe to the biggest one. But I mean, if you do not have a million token context, you will run into some. But with the million token context, with the apps I used, it wasn't an issue. I mean, of course, there is some compressing involved, which automatically happens by the engines. But I didn't have any issues like that.
Cool, thanks.
Just for the connectivity solution you analyzed there. Can you say the reliability improved when you
No, actually, I mean, now what you have now is I can provide you slow internet also on Ubuntu 26.04. So I mean, I can only provide what the backend provides. Now, I mean, now to clarify, what was implemented was this internet access. The private access on purpose I didn't implement because maybe someone would start to complain. But of course, so far, I do not have this horrible GUI app. I can just do it from the command line, so I for sure have less memory usage. Significantly.
Thank you.
In your experiments, have you thought a little bit about if you have, I don't know, some magic sauce trade secret that you absolutely would not want to leak, how you could engineer an implementation of that so that it is, with these tools, specifically not reverse engineerable?
Not give any customers access to the binaries. So I would just put everything as a service.
Okay.
Yeah. No. I mean, to be honest, I do not believe that you can obfuscate anything here. this zero trust thingy is actually doing some kind of obfuscating techniques which are completely meaningless.
Okay.
There's a
Thanks for this thought.
Perfect. Then I would say thank you very, very much,
Thanks a lot.
Daniel, for this excellent presentation.